Hi, so this is Dr. Matsuka again, and in this lecture I'm going to talk about the different sources of our electricity, different ways we can generate electricity, where it comes from, and also just a little bit briefly about how it impacts our environment. But firstly, I want to start off talking about conservation of energy, which is one of the most fundamental principles in physics or physical science in general, right? No matter what type of energy that we're talking about, whether it's electricity or chemical, light energy, whatever kind of energy, it has to obey conservation of energy, right? You cannot just create energy. Only God can create energy. He can say, "Let there be light." But for us, we can't just create light. We have to we have light appears as it's converted from something else. For example, in our flashlight, right, light comes from the chemical energy in a battery. So we're taking our chemical energy and we convert it to light energy, right? Or we use electrical energy, as shown in this picture down here. Right? We have electrical energy, that's what comes out of the power outlet, right? And then that converts into light, right? And this is how all of energy comes. We can only change it or convert it from one form to another. We cannot create energy, and we cannot destroy energy. Only God can do that. All that we are doing is converting, right? Our human bodies, right? Humans, right? Our digestive system, we convert chemical energy, which is our calories, our food, our nutrition, and that becomes mechanical energy. And that's what we can walk around and we can do our studies and work and things like that. Right. And so there are multiple forms of energy, right? So today's lecture is going to focus on electrical energy, but we're also going to collect electrical energy or convert or generate electrical energy from a variety of other energies, say chemical. I will talk about chemical and mechanical and light or solar, heat, right? Mechanical, we already said, yeah. So there are lots of different types of energies, but you can only convert one from one to another. Right. The first electricity or energy source I want to talk about is fossil fuels, because this is really the most common, energy source that we use around the world. Right, so fossil fuel is actually chemical energy, right? It's just in a bunch of molecules or atoms that have stored energy in their bonds, the chemical bonds. And so the energy is stored in these chemicals or in these molecules by once living organisms. Oops. So similar to how an apple has stored chemical energy and then we eat the apple and then we can convert it to mechanical, fossil fuels are basically like really old apples that we can then convert into electrical energy. And so most of these are actually from, the theory is that it's from millions of years ago. Most of them are from vegetation, from seaweed and things like that, that have been under the earth for a long time and have been processed by being squished by all of the earth's gravity. I don't want to get too in deep in that. But first, here I want to talk about how it's converted to electricity. There are three main types of fossil fuels. There's oil, also known sometimes as petroleum, and that's actually what we use as gasoline in our car. It's processed into gasoline. I don't know if converted is the right word. Actually, processed might be better. Process, right? So that's also what our cars run on, or most cars run on. The other one is natural gas, and the other one is coal. So oil and petroleum are mostly imported, And so that's why there's often tons of discussion among politicians and in the news about where we're getting our oil, and should we continue to get oil from Russia and OPEC, or should we go be independent? And that's a topic for serious consideration, but not for this lecture. Natural gas is mostly domestic, which means from the U.S. and it's more and more common that coming from fracking. So you might have read about fracking in the news, and it's just a new technique to get more natural gas out of the ground, so that we can collect more and more natural gas. But fracking has a lot of environmental concerns. It's basically putting potentially toxic chemicals into the ground in order to make the natural gas come out. And so you're putting various chemicals into the ground, potentially harming other farms nearby. Fracking also, people have said that it makes natural gas actually come up into the pipes and wells, and so people are getting natural gas in their water, their drinking water, and so there are many concerns going on with that as well, and a lot of major pushback. And then thirdly is coal. The U.S. actually has a lot of coal, and so we could depend solely on coal, but it's actually really dirty. Dirty as in it's very bad for the environment. It's also very bad for miners. You can get coal lung. It's very unhealthy for them. And so there's been a lot of discouragement about using coal, even though we have plenty of it, just because it's so bad for the environment and so bad for health. Right here on the right, I have a graph that shows, our electricity generation in 2000 versus 2018. And one of the biggest changes, or a couple of them, is how coal has decreased significantly, right? And that's mostly due to the environmental concerns and how dirty it is. And most of that has been made up by natural gas, right? So it's around this time, 2000, that fracking made it much easier to get natural gas. So now we're getting about a third of our electricity from natural gas. We get a ton from petroleum, oil. Again, that's also gasoline. That's where we get a lot of our things. And then up here above this line, we have our so-called renewables. Renewables or green energy, and that's what I'll spend most of this lecture talking about. But you can see it's about maybe 10% of our electricity, or less at this point. This is just a clearer graph that shows what's going on over time. Right, as I said, coal, which is here in the gray, has decreased significantly, whereas natural gas has increased significantly. My arrows are not nice. Okay, coal has gone down, natural gas has gone up. Renewables have actually increased steadily, and we will see if hopefully they will continue to increase. But that's a work in progress right now. And then nuclear. Nuclear is what I'm going to talk about exactly on the next slide. It's been very steady. Steady with slight decrease. All right, so what's going on with nuclear? What is nuclear? Okay, nuclear power converts energy held in the nucleus of atoms. So this is specific atomic energy. In the nucleus of atoms, there are the neutrons and the protons and how they interact. And actually, if you have some compositions of neutrons and protons are more stable than others, and some of them store more energy than others, right? So if you have particularly a very large nucleus, it actually wants to break up into two nucleuses, and when it does that, it will release energy. But the physics of releasing this energy is very tricky. There's a lot of like explaining how exactly the energy comes out and how exactly the nucleuses break up. That physics was only discovered recently. I'd say maybe like in the 1930s or 40s. Right, demonstrated by the nuclear bombs. And basically, when they came up with a nuclear bomb in World War II, that was based off of science. That was is also as a big help in nuclear power. And so how to actually get that energy and how to actually get these nuclei to break up is complicated. There's actually a lot of engineering that needs to go into it as well. But there is a lot of energy there. The energy that is stored in nuclear energy is very powerful, as demonstrated by Hiroshima and Nagasaki. There's a lot of energy, and hopefully, potentially, we can use that energy to create electricity rather than destroying people. So there are really two types of releasing nuclear energy. One is fission and one is fusion. Fission is well established. The nuclear bombs used in World War II were based on fission, and basically every power plant that's out there is based off of fission. You get a lot of energy. It's mostly out of uranium or plutonium, and they've figured out how to engineer these power plants, such as up here. There's our power plants, right? That should remind you of, or reminds me of The Simpsons. I don't know. Yeah, that's my generation. But this is very well established. The only concern is it produces what's usually called a nuclear waste or hazardous waste, and there's a variety of different wastes that are coming out, but most of them can cause cancer or death, and they're very dangerous. And then there's continued discussion of where should we store the nuclear waste? How should we store it? Should we put it underneath a big mountain and put it inside some really solid containers that can hold it for 5,000 years? Is that sufficient? But what if someone breaks in and steals it or something? And so that's a major policy issue as well. So there's a second type of nuclear energy called fusion, and that's still being researched. There's a lot of interest in it and a lot of work in it, but the physics of fusion is actually even more complicated than the physics of fission, and even more than that, the engineering in order to enable fusion is it's a lot of work. People have spent hundreds of billions of dollars researching and trying to build a fusion power plant. But they still have not succeeded, and it's still a work in progress. The key aspect of fusion that makes it the most interesting is that instead of producing nuclear waste, it produces water. It produces plain old water, which you can drink or you can just do whatever you want with. It's nowhere near as hazardous as what comes out of fission. And so that's one of the compelling reasons of why we're still continuing to research fusion, right? The common joke among people who study fusion or energy is that fusion power plants are 20 years away, right? So this is 2020. So that's saying right now they're expecting that it will be up and running around 2040. But they've always said it'll be 20 years away. 10 years ago, they said it'd be 20 years away. 20 years ago, they said it'd be 20 years away. But it's still not here. And so there's some concern that it's just unachievable. But we're still working on it. Hopefully it'll get there someday. All right, so moving on to the more renewables, right? So the term renewable, right? Modern renewable energy. There's still discussion and argument over what renewable should really stand for. I think the terminology that's used here in this graph is most common, right? That it has hydropower, which is basically due to water, wind, solar, and then others such as biofuel, geothermal, wave, tidal, etc. Most of these I'm going to cover in the slides to come. Nuclear, some people put nuclear as a type of renewable energy, or they at least call it a clean energy because at least it's not fossil fuel, it's not putting out carbon dioxide. But that's it's still, there's no consensus, at least in my understanding of where nuclear really should lie, because it's definitely not a fossil fuel, but it's also not a renewable. Renewable usually depends on something that we continue to get new stuff every day. We don't continue to get new uranium every day. All right. But anyway, so let's set nuclear aside. And this is renewable. This is renewable energy consumption for the whole world from 1965. And if we look really old, long time ago, all we have is hydro, which is water power. Right? And so hydropower has been used since the beginning of the industrial age. Basically, people have figured out how to use water as it's going down with gravity and use it to make windmills and things like that. Not windmills, but different mills. And so, or even like steam turbines. So it's been used for hundreds of years. But more and more, like maybe we can say back in like the 1980s or so, we get more renewable energies are increasing. That has to do with the oil crisis. And so we can see significant, like wind has become a significant chunk. Solar is growing. Then there's a lot of other renewables that are starting to expand. So I'm going to talk just briefly about these different renewable powers, touch on each of these here. All right. So first, hydropower, right? As I mentioned, this is something that's been around for a very long time. It uses gravity or gravitational potential energy of water, right? As the water is flowing down the hill, right? Is flowing downhill. You use that in order to convert it to energy, convert it to electricity. Right? So this is usually done in dams, right? You have water that's coming down, and then as it goes down the hill, you use that energy and you create electricity. So it's been around a while, and so basically all of the best sites have already been taken, right? And so there's very few places left where we can actually get more hydroelectricity. So we don't expect it to grow much more. And also, in order to create these new dams or to collect more hydropower, it actually causes significant damage to the environment, loss of agricultural land, even people have to move, right? Because in order to put a dam, you're basically going to widen the lake, right? And this was, we haven't done this recently, or hasn't been in the news recently, but maybe a couple of decades ago, you had the Three Gorges Dam in China, where they had to make, hundreds of thousands of people move so that they could create this huge dam. So they got a lot of electricity through it, but there was a lot of damage to the land, and then a lot of just movement of peoples in order to create more hydropower. So hydropower is very natural. I mean, it's the gravity of you just collecting gravity of water and converting it to electricity. But in order to create these power plants, there's a lot of damage to the land that you have to do. All right, the next one I want to talk about is wind power. Wind power has been used in minor ways for a long time, especially to grind grains, as I mentioned, windmills. And so we've known that wind has energy that can be utilized. The actual creation of these wind turbines have become more common in the past 20 decades. past 20 years or a few decades or so. Basically, you use wind if it's strong enough, and it turns these windmills, and then you create electricity. I don't know if you can read that. All right, so each of these windmills creates electricity, but only when it's turning. And so you have to put these in places where the wind is strong enough, and also you want it to be, you want it to last for a long time. You don't want to just come and burst. It should be throughout the day. And so there's only specific locations where this will be beneficial. It's also, I don't know, some people say it's not aesthetic. I actually think they look cool, but a lot of people complain they don't want to see them in their backyards. So there's numerous complaints about they don't want people who don't want these in their backyards, or they don't want to listen to them. There have been claims that the sound has affected their mental ability or things like that, although I don't think any scientific evidence has supported that. But there is a lot of concern about this and how it affects things. But there's no waste at all. There's no pollution coming from this at all. So it is fairly clean. Very minor environmental effects. But there's still a lot of pushback. But it is growing. It is growing. All right, solar. Solar is kind of, or is close to my heart, because that's what I did my my PhD research on. Basically, you have all of this sunlight coming in, right? We naturally get tons of sunlight. Oh, sorry. We naturally have tons of sunlight. It comes in, it hits all of these things called panels, and then it goes into the electricity, right? So building these panels, there's a lot of science and engineering that goes into that, of converting the sunlight into electricity. And that's what I did for my research. I thought it was really cool. The physics of it is like really awesome. So if you ever want to know anytime, please ask me, and I would be happy to talk your ear off about how solar power works. But I'm going to try to avoid doing that here. It is very promising. I will say it's very promising. There's no hazardous waste. These panels, sometimes they are made out of some dangerous chemicals like mercury or cadmium, but they're stuck in the panels. So as long as you don't try to eat your solar panel, you'll be totally fine. And so that at one point that was a major argument against using solar power, but it's basically been disproved that as long as you don't eat the solar panel, you'll be totally fine. Right, and there is, as I mentioned before, there's a growing amount of solar power already in use now, but there are so many more applications that are possible. You could put this on every roof, and you wouldn't have to look at it. I guess it would change how your roof looks. You could, especially there's a lot of potential for solar in countries that are developing rapidly, including in Africa and Southeastern Asia and South Asia. There's so much solar, so much sunlight that's available there, and there's such a need for electricity. That's why I personally believe that solar power really deserves to be looked at and propelled all the more to help these developing countries. Anyways, there's a lot of room for growth if only we can get there. And these solar panels are not that cheap, but they last for a long time, so they end up being worth it in the end, but then you got to put in the investment, and so that's also one of the things hindering it. All right, a couple of less common things. Geothermal energy, again, is very site specific, right? It depends on you being somewhere where down in the ground is very hot. And so that's usually somewhere with volcanoes. Volcanoes or geysers. Right? So this is only useful at places that have basically volcanoes or geysers, that they have somewhere really down deep in the ground, they have a lot of heat. And so Iceland is actually a key example of this. And Iceland gets the majority of their electricity from geothermal energy. They're perfectly placed in order to collect a lot of geothermal energy. Hawaii also, as you can imagine, uses a large chunk of geothermal, but not as much as Iceland. So there are specific places where there's a lot of potential, but it's very specific places. So it's not of that much interest to the world at large, in my opinion, at least. A last one I want to talk about is biofuels. There's been a lot of interest and talk about biofuels, especially in the past decade or two, as something that's so potentially clean, right? The idea is to take like some corn or sugarcane. A lot of the U.S. is working on corn. Basically, the idea is to grow extra corn and then use it, process it to make ethanol. And then ethanol, it can be used as gasoline, or can be mixed with gasoline, or it can be used purely as basically gasoline, used to fuel cars, or we can use it basically instead of a fossil fuel. We can burn ethanol, and so the idea is we can use a lot of our fossil fuel infrastructure, but instead of using these fossil fuels that take millions of years to make, we can instead use corn, which we can grow every year. And so there is an appealing argument to that. But actually, it takes a lot of energy to make corn and to make ethanol. And there have been numerous studies that show there's more energy used in the production of ethanol, basically in planting this corn and growing the corn and then processing the corn, than we'll actually get from burning the ethanol itself, right? So we're actually losing energy by making ethanol, right? Versus fossil fuels, where we didn't make the fossil fuels, we've just taken it out of the ground, and so that's why we're not losing any energy. But these biofuels, we are talking about making it, and then we lose, and then it's less efficient. We're actually wasting energy. But the pushback on that is, well, this is still mostly in the research phase. We're still figuring out how to make biofuels more efficient. And so perhaps, hopefully in the next few years, it'll actually be more efficient to make the ethanol. And so then we'll actually be gaining energy by making this ethanol and then burning it. That's possible. It's not guaranteed. I don't know. It's also kind of ironic that basically, especially here in the US, we have so much food that we want to use this food in order to power our cars, whereas there are plenty of places around the world that don't have enough food. But that's just the irony of being an American or being in a developed country. So there's a lot of interest in biofuels. I don't know if I support it. But you should be aware of what it is because there's a lot of interest in it. All right, so that's it. So those are the highlights of different electricity sources. I just want to give you a taste. I encourage you to go look online and read more and as much as possible of where our electricity comes from and what sources are clean or how clean, things like that. But I'll leave that to you. So thank you for listening to the lecture. I'll see you again online.